Here is a number, 93 billion. That is the diameter of the observable universe in light years, and I can almost guarantee that number meant absolutely nothing to you. It went in, your brain registered it as very big, and moved on. Because that's what brains do with numbers like that. They bounce off. And that's not your fault. It's not a failure of intelligence or imagination. It is a fundamental feature of how human minds work. We evolved to survive on a single planet, in groups of 50 people, worrying about distances of maybe a few hundred kilometers at most. The universe did not consult us when it decided how big to be. So today, we are going to try something different. We are not going to throw big numbers at you and hope they stick. We are going to build the scale of the universe from the ground up, starting with something you can hold in your hand and expanding outward, step by step, until we reach the edge of everything we can see. And I want to warn you, at some point in this video, something is going to click. The scale is going to land in a way that feels different from just hearing a statistic. And when it does, it tends to feel like the ground shifting slightly beneath your feet. Let's start small. Pick up a marble. A standard glass marble about 1.5 centimeters across. That marble is your reference point. Hold on to it. Now. If that marble were the Earth, our entire planet, everything that has ever lived, every ocean, every mountain, every city, every human being who has ever existed, then the moon would be about 43 centimeters away, less than half a meter. You could hold the Earth in one hand and reach the moon with your other hand without fully extending your arm. That's the Earth-Moon system, the thing that drives our tides, that ancient humans worshipped, that we actually sent people to. All of it fits within arm's reach on this scale. Now let's bring in the sun. On the same scale, where your marble is the Earth, the sun would be about 1.7 meters in diameter, roughly the height of an adult human being, and it would be 176 meters away, about the length of 2 football fields. So picture this. You are holding a marble. 176 meters down the road, there is a person-sized glowing sphere. That is the Earth-Sun relationship. That is the distance that sunlight crosses in 8 minutes to reach you. That is the distance that has kept our planet warm and alive for 4.5 billion years. And here is the first thing that should give you pause. That gap, 176 meters, on our marble scale, is almost entirely empty. There is nothing in it, just vacuum. Just the occasional photon screaming across it at the speed of light. Now let's zoom out a little further and fill in the rest of the solar system. On our marble scale, Mars is about 284 meters away. Jupiter, the largest planet, a gas giant so large that 1,300 Earths could fit inside it, is about 900 meters from your marble, still smaller than a kilometer on this scale. Saturn, with its extraordinary rings, is 1.6 kilometers away. Uranus is 3.2 kilometers. Neptune, the furthest recognized planet, the one Voyager 2 flew past in 1989 after a 12-year journey, is 5 kilometers from your marble. 5 kilometers, on a scale where the Earth is a marble. That is the solar system. That is the full extent of the neighborhood our sun gravitationally dominates. 8 planets, dozens of moons, billions of asteroids and comets and chunks of rock, all of it in 5 kilometers around a marble. And beyond Neptune. On our marble scale, the nearest star, Proxima Centauri, is 47,000 kilometers away. Let me say that again. If Earth is a marble in your hand, the nearest star is 47,000 kilometers away. That is further than a flight from London to Sydney and back, 6 times over, on a scale where our entire planet fits in your palm. The solar system, vast as it seemed a moment ago, is a tiny bubble of warmth and light in an ocean of almost incomprehensible emptiness. Before we go any further, I want to pause and explain something, because you might be sitting there thinking, okay, I'm following this. These analogies make sense. I think I'm getting it. And I want to gently tell you, you're not. Not really. And that's okay. Here's why. The human brain has a system for processing numbers and quantities that works brilliantly up to a point. Small numbers, 1, 5, 10, we understand instinctively and immediately. You don't need to count a group of 3 apples. You just see 3. Slightly larger numbers, dozens, hundreds, we can visualize with a bit of effort. A crowd of 100 people, a jar of 200 coins. But somewhere around 1,000, something starts to break down. Psychologists call it numerical magnitude insensitivity, the technical term for the fact that our intuitive grasp of numbers stops scaling with the actual numbers. 1,000,000 and 1,000,000,000 both feel like a lot. 1,000,000,000,000 feels like a very large lot. The emotional and intuitive weight we assign to these numbers does not match their actual mathematical relationship. 1,000,000 seconds is 11.5 days. 1,000,000,000 seconds is 31 years. 1,000,000,000,000 seconds is 31,000 years. These numbers are not in the same universe of magnitude, but to most human brains, unprimed, they feel roughly similar. Now apply that to space. The distance from the Earth to the Moon is about 384,000 kilometers. The distance from the Earth to the Sun is about 150 million kilometers. The distance to Proxima Centauri is about 40 trillion kilometers. The diameter of our galaxy is about 946 quadrillion kilometers. Those numbers do not just fail to land, they actively mislead, because they look like numbers we've seen before, familiar shapes, familiar digits, but they represent something our minds have no architecture to hold. This is not a bug in human cognition. It's a feature. We evolved on a planet where the distances that mattered were measured in meters and kilometers. Our ancestors, who spent mental energy trying to intuitively grasp interstellar distances, were not better survivors than those who didn't. So we didn't evolve that ability. What we did evolve is the capacity for analogy, for story, for building understanding by comparison, which is exactly what we're doing here, and why we need to keep going. Let's keep zooming. We've established that on our marble scale, the nearest star is 47,000 kilometers away. Now here's the staggering part. Proxima Centauri is one of the closest stars to us. Our galaxy contains somewhere between 200 and 400 billion stars. Let's try a different analogy. Imagine you are standing in the middle of a desert at night. The sand stretches to the horizon in every direction. Now imagine that every grain of sand in that desert is a star. That's roughly how many stars are in the Milky Way. Actually, that's not quite right. There are an estimated 7.5 quintillion grains of sand on all of Earth's beaches combined. That's a 7.5 followed by 18 zeros. Our galaxy contains somewhere around 300 billion stars, so the Milky Way has fewer stars than there are grains of sand on every beach on Earth. Still a staggering number. But now sit with the next part. Our Sun, the enormous 1.4 million kilometer wide ball of nuclear fire that our entire solar system orbits, is one of those grains of sand. It is so average, so unremarkable in the context of the galaxy, that it doesn't even merit a name beyond the Sun. There are stars in the Milky Way so large that if you place them where our Sun sits, they would swallow Mercury, Venus, Earth, Mars, and extend past Jupiter. Our Sun is a slightly below average grain of sand on a beach of 300 billion grains. Now, let's talk about the size of that beach. The Milky Way is approximately 100,000 light-years across. Light, the fastest thing in the universe, traveling at 300,000 kilometers per second, takes 100,000 years to cross our galaxy, from one side to the other. To put that in driving terms, if you drove at motorway speed, non-stop, 24 hours a day, it would take you roughly 1.1 trillion years to cross the Milky Way. The universe itself is only 13.8 billion years old. You would need to make that drive about 80 times back to back, starting before the Big Bang, and you still wouldn't be finished. And we live in the suburbs. Our solar system sits about 26,000 light-years from the galactic center, roughly halfway out from the core on one of the Milky Way's spiral arms. On the scale of the galaxy, we are not in the middle. We are not even in an interesting neighborhood. We are out in the quiet outskirts, far from the dense, ancient, supermassive black hole that anchors the center of everything. The Milky Way is not alone. Our galaxy has neighbors. The large and small Magellanic Clouds are satellite galaxies, small irregular galaxies that orbit the Milky Way like moons orbit a planet. You can see them with the naked eye from the southern hemisphere, two smudges of light in the night sky, each containing billions of stars. And then there is Andromeda. The Andromeda Galaxy is the largest member of what astronomers call the Local Group, the cluster of around 54 galaxies that our Milky Way belongs to. Andromeda is roughly 2.5 million light-years away. On a clear night, in a dark enough sky, you can see it with the naked eye as a faint smudge near the constellation of the same name. Think about that. The furthest thing you can see with the naked eye, unaided, is a galaxy containing 1 trillion stars, 2.5 million light-years away. The light you are seeing left Andromeda when our ancestors were early Homo species, still millions of years from developing language, fire, or any concept of looking up. Now here's something that tends to sit uncomfortably. Andromeda and the Milky Way are heading toward each other at roughly 110 kilometers per second. In about 4.5 billion years, they will collide and merge into a single, larger elliptical galaxy. Astronomers have already named it Milkomeda. It sounds catastrophic. But here's the thing. Galaxies are so vastly empty that even when two of them collide, individual stars almost never actually hit each other. The chance of our Sun colliding with another star during the merger is essentially zero. Galactic collisions look dramatic from a distance, but they're more like two clouds of smoke passing through each other than two bricks hitting. The local group itself, all 54 of those galaxies, spans about 10 million light-years. 10 million. And it is, in the context of the observable universe, a tiny neighborhood. Zoom out further and the local group becomes a dot. Galaxies cluster together under gravity, forming galaxy clusters, structures containing hundreds to thousands of individual galaxies, each galaxy containing hundreds of billions of stars. The nearest major cluster to us is the Virgo cluster, containing over 1,300 galaxies, sitting about 65 million light-years away. The Milky Way, along with the rest of the local group, sits on the outskirts of a larger structure called the Virgo supercluster, a vast filament of galaxy groups and clusters stretching about 110 million light-years across and containing an estimated 100 galaxy groups. But even that is not the full picture. In 2014, a team of astronomers led by Brent Tully at the University of Hawaii redrew the map of our cosmic neighborhood. Using measurements of how galaxies move, not just where they are, but where gravity is pulling them, they defined a supercluster they named Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea contains the Virgo supercluster, our local group, and hundreds of thousands of other galaxies. It stretches 520 million light-years across and contains the mass of 100 million billion suns. And Laniakea is one supercluster. The observable universe contains an estimated 10 million of them. Zoom out far enough, to scales that would make even Laniakea invisible, and something remarkable appears. The universe is not a random scattering of galaxies. It is structured. Galaxies cluster into filaments and sheets, separated by vast, almost completely empty voids. The whole thing looks unmistakably like a cosmic web, a three-dimensional network of glowing threads and dark gaps that stretches across billions of light-years. It looks, if you've ever seen an image of it, almost biological, like neurons firing in a brain, like the network of blood vessels in a body. Scientists are careful to say this is coincidence. Similar physics produces similar structures at very different scales, but the resemblance is striking enough that it stops almost everyone who sees it. And now we reach the limit. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, is approximately 93 billion light-years in diameter. That is the number we started with, the one that bounced off. Let me try once more to make it land. If the entire observable universe were shrunk down to the size of Earth, our whole planet representing all of space and time we can see, then the Milky Way, our entire galaxy, would be roughly the size of a house. Not a city, not a neighborhood, a single house on a planet-sized map of everything we can observe. That is where we live. Inside something roughly the size of a detached house on a planet that represents the entirety of the observable universe. Because here's the part that tends to make people go very quiet. The observable universe is not the whole universe. It is just the part we can see. The sphere defined by how far light has been able to travel since the Big Bang, 13.8 billion years ago. Beyond that boundary, space continues. We have no idea how far. Some models suggest the full universe is at least 250 times larger than the observable portion. Some suggest it may be effectively infinite. We don't know. We can't know. The information simply hasn't reached us yet, and in an expanding universe, some of it never will. We are, in the most literal sense, looking out at only a small window of everything that exists. Here's one more piece of the puzzle that changes how you see the night sky. When you look up at a star, you are not seeing it as it is now. You are seeing it as it was when the light you're currently receiving left it. And depending on the star, that could be a very long time ago. The sun, 8 minutes of light travel away, you're seeing as it was 8 minutes ago. Trivial. Proxima Centauri, you're seeing it as it was 4 years ago. Sirius, the brightest star in the night sky, as it was 8.5 years ago. Betelgeuse, the red giant in the shoulder of Orion that may or may not explode into a supernova soon, as it was approximately 700 years ago. The light reaching us from Betelgeuse right now was emitted around the time of the Black Death. We have no idea what Betelgeuse actually looks like today. It may already be gone. The Andromeda Galaxy, as it was 2.5 million years ago, before modern humans existed. The most distant objects we've ever observed with telescopes, galaxies near the edge of the observable universe, as they were 13 billion years ago, when the universe was less than 1 billion years old. Those galaxies almost certainly no longer exist in the form we're seeing. They have since evolved, merged, changed utterly. We are looking at their ancient light, long after the source has moved on. The night sky is not a window into space. It is a window into time. Every point of light is a message from the past, arriving at different delays, building a picture of the universe not as it is, but as it was across billions of years of history, all arriving at your eyes simultaneously. So, your brain can't handle the scale of the universe. We've established that. No human brain can, fully. Not even the astronomers who spend their careers measuring it. But here's the thing I want to leave you with, and I mean this genuinely. You are made of atoms. Specifically, you are made of atoms forged in the cores of stars. The carbon in your body, the oxygen you're breathing, the iron in your blood, none of it was made on Earth. All of it was made inside stars that lived and died before our sun existed, scattered across space in supernova explosions, drifting through the galaxy for millions of years, before slowly coalescing into a solar system, a planet, and eventually, you. You are, in the most literal scientific sense, made of star stuff. And you are the only part of the universe, as far as we know, that has ever looked back at itself and wondered about its own scale. The Milky Way does not know it exists. Andromeda does not know it's heading toward us. Laniakea has no awareness of being immeasurable. But you do, with a brain that evolved to find food on a single savanna, in a body that lives for less than a century, on a planet so small it's invisible from the edge of the solar system. You have somehow managed to map the universe, to measure the distance to galaxies, to calculate the age of the cosmos, to understand, at least in outline, the shape of everything. That is not a small thing. That is extraordinary. The universe is 93 billion light-years across, and somewhere in it, on a pale blue dot orbiting an average star in the suburbs of one of hundreds of billions of galaxies, something became curious enough to ask how big it all was, and then actually figured it out. If that doesn't give you a reason to feel something, I don't know what will.